In this video, we're going to take a look at elementary matrices. A matrix E is an elementary matrix of type 1 if it can be obtained by exchanging exactly two rows of the identity matrix I. So observe this illustration. We have the identity matrix, and then we are performing a type 1 elementary row operation to obtain this new matrix. The new matrix is an elementary matrix of type 1. A matrix E is an elementary matrix of type 2 if it can be obtained by multiplying one row of the identity matrix I by a non-zero constant. So here we are illustrating that. Here is the identity. We're performing a type 2 elementary row operation, multiplying row I by a non-zero constant, lambda, to obtain this resulting matrix, which is an elementary matrix of type 2. A matrix E is an elementary matrix of type 3 if it can be obtained by adding a constant multiple of a row of I to another row of I. Here we're illustrating. We have the identity matrix. We're applying a type 3 elementary row operation where we are taking row J and we're adding C times row I to it. So we took a row J, multiplied row I by C, and added to row J. And this is the result, the resulting matrix. This is a type 3 elementary matrix. Notation. We will denote the type 1 elementary matrix where the ith and jth row of the identity matrix are interchanged by the notation ELEM parenthesis RI interchange RJ parenthesis. This denotes this is the elementary type 1 matrix where the ith and jth row of I are interchanged. We denote the type 2 elementary matrix where we apply a type 2 elementary row operation to I, specifically multiply the ith row of I by lambda not equal to 0. We denote that by the notation ELEM parenthesis lambda RI parenthesis. Here lambda is different than 0. That right there is understood to be the elementary matrix that is obtained by multiplying the ith row of the identity matrix by lambda different than 0. Finally, the type 3 elementary matrix where lambda times the ith row of A is added to the jth row of A, where lambda is different than 0, is denoted by ELEM parenthesis RJ plus lambda RI parenthesis. That is understood to stand for the elementary matrix of type 3 where lambda times the ith row of I is added to the jth row of I. If you wanted to explicitly say this, we could say that is the elementary matrix where lambda times the ith row of I is added to the jth row of I. Here is a property. If you give me a matrix, let's say n by n, and I multiplied from the left by type X elementary matrix, where X could be 1, 2, or 3. Then the result, EA, will be what happens when you perform that type row operation to A. So let's read. Multiplying a matrix A from the left by an elementary matrix E of type X performs an elementary row operation on A of the same type X. More specifically, if E is a type 1 elementary matrix, EA is the matrix obtained by applying that type 1 row operation to A. So if E equals the elementary matrix where the ith and jth rows of A are interchanged, EA is the matrix obtained by interchanging the ith and jth rows of A. If E is a type 2 elementary matrix, EA is the matrix obtained by multiplying the ith row of A by lambda, where lambda is not equal to 0. And finally, in 3, if E is a type 3 elementary matrix, where the ith row of I is multiplied by lambda and added to the jth row of I, then EA is the matrix obtained by adding lambda times the ith row of A to the jth row of A. For example, let's begin. So let A be a 4 by 5 matrix. Describe EA for E equals to the elementary matrix, the 4 by 4 elementary matrix, where the fourth row of I is multiplied by -5. Then for the type 3 elementary matrix, where the -3/5 of the first row of I is added to the third row of I. The elementary matrix of type 1, where the first and fourth rows of I are interchanged. We have also a matrix, a matrix where the first row of I is unchanged, the second row of I is multiplied by 2, the third row of I is multiplied by 3, the fourth row of I is multiplied by 4. Okay, so let's do the multiplication. When I multiply A from the left by this type 2 elementary matrix, that will be the same as applying that type row operation on A. So the description is A is going to be the 4 by 5 matrix where it's the fourth row is simply -5 times the fourth row of A. Second one, EA is going to be the matrix obtained by applying the elementary row operation R3 minus 5/3 R1. EA for the elementary matrix, where the 4x4 elementary matrix, where the first and fourth row of I are interchanged, then EA is going to be the 4x5 matrix, where the first and fourth rows of A are interchanged. Finally, for E, that is obtained by multiplying the second row of I by 2, the third row of I by 3, and the fourth row of I by 4. EA is going to be the 4x5 matrix, where its second row is obtained by multiplying the second row of A by 2. The third row is obtained by multiplying the third row of A by 3. And the fourth row is obtained by multiplying the fourth row of A by 4. Solutions. For the 4x4 elementary matrix E, where the fourth row of I is multiplied by -5, EA is the 4x5 matrix with rows 1, 2, and 3 identical to those of A, and with row 4 equal to -5 times the fourth row of A. So here is the fourth row of EA, -5 A41, -5 A42, all the way up to -5 A45. So explicitly, what is EA? Well, EA is all of A from rows 1 to 3. So you have A11, A12, all the way to A15, A21, A22, all the way up to A25, A31, A32, up to E35, but then its fourth row is -5, A41, -5, A42, up to -5, A45. For the 4x4 elementary matrix, where we're adding -3/5 of row 1 to row 3 of I, EA is the 4x4 matrix, is the 4x5 matrix, with rows 1, 2, and 4 identical to those of A, and with row 3 equal to -3/5 times the first row of A added to its third row. So here is the third row of EA. A31 minus 3/5 A11, A32 minus 3/5 A12, all the way up to A35 minus 3/5 A15. Okay, so for the 4x4 elementary matrix, where the first and fourth rows of I are interchanged, EA is the 4x5 matrix obtained by interchanging the first and fourth rows of A. So specifically, EA is the matrix A41, A42, A43, A44, A45, A21, A22, all the way up to A25, A31, A32, all the way up to A35, and then A11, A12, A13, A14, and 15. So observe here that this is the result after you interchange the fourth and the first rows of A. Now, for E equals to the 4x4 matrix, whose first row is the same as the first row of I, whose second row is 2 times the second row of I, whose third row is 3 times the third row of I, and whose fourth row is 4 times the fourth row of I, EA is the 4x5 matrix obtained by multiplying the second row of A by 2, the third row of A by 3, and the fourth row of A by 4. Okay, observations. Our first 3 matrices were elementary matrices, but the fourth one was not. The matrix whose first row is 1, 0, 0, 0, second row is 0, 2, 0, 0, 0, third row is 0, 0, 3, 0, fourth row is 0, 0, 0, 4, is not an elementary matrix. Okay, that is all for elementary matrices. Thank you for watching.